Good day everyone, and welcome to where we are putting together solutions to those math and science areas that students are getting problems with. In this video, we'll be looking specifically at CSEC Mathematics and the topic of algebra. We'll be looking at the questions that came in the CSEC exam from May 2009 until 2013. Feel free to like the video and add any comments down below so we can help make other videos that will be assistance to you. Don't forget to look at the description down below where we have outlined the order in which you should look at all the CSEC Math past paper videos we created to cover the entire syllabus from May 2009 until the present. Let's look at the 10 major topics in CSEC Math. And in this video, we'll be looking at topic number 6, Algebra. Algebra is tested in both section 1 and in section 2. It comes for 6 questions in the multiple choice, paper 1 out of a possible 60 questions. And as this video is looking at algebra in section 1, it comes for 1 question in section 1 worth 10 marks out of the total of 100 marks for paper 2. It appears as number 2 for every past paper question from May 2009 until 2013. May 2009, number 2A, factorize completely, part 1. 2ax plus 3ay minus 2bx minus 3. Now, if we're going to factorize this, let's look at the first 2 terms, which we have underlined in maroon. If we look at that, we can see what is similar in both terms, the variable a. As such, we can extract a, factorize it, pull it outside the brackets, and that will give us a, and in brackets, what is left? 2x plus 3y. And we can check that back. If we multiply a times 2x, it will give us our first term, 2ax. And if we multiply a times 3y, it will give us our second term, 3ay. And now let's look at the next 2 terms. We have that underlined in purple. And if we have minus 2bx minus 3, then what can we pull out? We can pull out the minus b from it. And we're left with 2x plus 3y. Since both of them have the same brackets, 2x plus 3y, then we can extract that. And what are we left with? A minus b by 2x plus 3y. And let's remember, it doesn't matter which brackets we write first. We can put the 2x plus 3y in front and a minus b after, because multiplication is commutative, which means we can switch it and it'll still give us the same answer. Let's look at part 2. 5x squared minus 20. So if we're going to factorize that, then the first thing we can pull out is 5. And that will give us 5 by x squared minus 4. And there are many students who stopped here, but that is only partial factorization, meaning that there are more things we can do. So let's see. 5 by x squared minus 4. If we look at that, we have a term in x squared. We have no term in x. And then we have a term without x. As such, we can write it 5 by x squared plus 0x minus 4. This is a longer way to do it, but I want to make sure, so in case you get in problems, you can follow. There's no term in the middle, so we put it as 0x. Now, when we're considering factorization, what we're actually looking at is the coefficient or the number in front of the x squared times your last term, which is 4. So if I put it up here, I have 4 squares. 1 times 4 is 4. And what we want to do is be able to find any pair that will give us that 4. So we can rearrange these 4 squares, which are in a straight line, into groups of 2. So it looks like a square, so we'll have 2 by 2. So any combination of these, right, is what we're looking at, either 1 by 4 or 2 by 2. Now, which combination, the 1 and the 4 or the 2 and the 2, which one will give us 0x? What we're doing is we're taking 3 terms, x squared plus 0x minus 4, and breaking it up into 4 terms. If you look at a couple of our videos on factorization to get further explanation, we have some with a lot of examples in it. So if we use 1 and 4, and whether we add them or subtract them, it won't give us 0. But if we use 2 and 2, then it should give us that. So let's look at the combinations that we can use. Is plus 2 equal to 0? It's not. What about minus 2 plus 2? Yes, that gives us 0. 0 is also equal to plus 2 minus 2. And 0 is not equal to minus 2 minus 2. And the point in this is that many students get problems with factorization because they're not too sure exactly what we're doing. So what are we doing? We're finding a pair, since we have 1 times 4, 1x squared, that's the 1, and the 4 at the end. And that will give us 4. So we're looking for any pair of numbers which, when you multiplied, will give us 4. 1 by 4, 2 by 2. Now that we did that step, now we're going to look at the middle term, the term we have underlined in green, and which pair will give us that term, which will give us 0. And when we're looking at that, we're saying either we're taking the 2 and the 2, and we're changing the signs in front of them. So plus 2, minus 2 plus 2, and so on and so forth. So which one gives us 0? Either the second or third, both will work. So we can rewrite these 3 terms into 4 terms. How? By splitting the 0x into 2x minus 2x. Because 2x minus 2x is 0x. So we're not really doing anything to see. And now we have in our next line here 4 terms. So let's look at the first 2 terms. These 4 terms looks like the question above, which we had underlined in maroon, the first 2 terms. So we're doing the same thing here. And x squared plus 2x, what's the same in both of them? X, we can pull it out. So we're left with x plus 2. And we underline the second 2 terms in purple, just like above. And that is minus 2x minus 4. What we can pull out from there, but we can factorize, minus 2. So we're left with x plus 2. And if we look at what is inside the square brackets, the x plus 2 is the same. So we can rewrite it in our final line. That will give us 5 by x plus 2 by x minus 2. Where did we get the x minus 2 from? From the terms that were outside the brackets. There's a shorter way to do this if you memorize the results, and that is 5x squared minus 20. We can pull out the 5, so we're left with x squared minus 4. And if you look at that, that is like a squared minus b squared. So many teachers teach it this way, and that's okay too. Right? Remember, every single question in maths, there are multiple ways of solving them. 2, 3, 4, 5 different ways of solving every single question. Sometimes the teachers don't take the time to teach multiple ways, or they found that certain students get confused by teaching more than one method. So they stick to one basic method. So we're doing the same thing here. So 5 by x squared minus 4. If we look at x squared minus 4, that is really x squared minus 2 squared. So it looks like the form a squared minus b squared. So if we have anything like that, then we can say the answer, when we factorize it, will be a plus b by a minus b. So we can write our final line 5 by x plus 2 by x minus 2. That's a standard for anything of that form. And for part 3, last part of the question, 3x squared plus 4x minus 15, if we're factorizing that, it's the same thing like what we did there in our third line in part 2. We had 3 terms, we want to get 4 terms. So how do we get 4 terms? Then we want to figure out, first of all, we're multiplying the first coefficient of x squared by the 15. 3 times 15 is going to give us 45. So we can write 1 by 45. Or if we take the 45 and slide it around, we can get 3 rows of 15. So we had 1 row of 45. I didn't put it because it's too long to fit. And then 3 rows of 15. And if we shift this down, can we get 4 rows? No, we can't get 4 rows of anything. That won't give us 45. Can we get 5 rows? Yes, we can. We can get 5 rows of 9 or 9 rows of 5. Can we get anything else to give us 45? Anything 6 times anything will give us 45? No, it won't. 7 times? No. 8 times? And using your tables here, it won't. 9 times? We already have 9 times. 5 nines are the same thing as 9 fives. As such, we found 3 possible pairs that gives us 45. So now we have to decide which one of these pairs we're going to use to give us the middle term, which we've just underlined in green. So the middle term is plus 4. So can 1 and 45, can we do something with that to give us 4? No. 3 and 15, think about it a little bit. No, we can't. 5 and 9, maybe we can do something with that to give us plus 4. So let's see, plus 4, is that equal to plus 9 plus 5? No, it's not. Right, so if we had 2 positives in front of the 9 and the 5, it doesn't work. Let's try changing the sign. So plus 4, will that be equal to 9 take away 5? Yes, it does. So that means that's what we're going to use. But let's check the others to see. All we're doing, I'm trying to give you 4 lines, just like before in part 2, to show you the changing of the sign. So you can see is one of these combinations is going to give us a plus 4. Let's look at if we put minus 9 plus 5, that doesn't give us plus 4. It's not equal to that. Minus 9 minus 5, the 4th line, it doesn't give you plus 4 either. As such, to give us plus 4x, we can break that up into plus 9x minus 5x. So we can rewrite our first line, and it gives us our second line, moving from 3 terms to 4 terms. The 3x squared plus 9x minus 5x minus 15. The 3x squared remains the same. The minus 15 remains the same at the end, and the plus 4x is broken up into 2 parts. So we now have 4 terms. And the question now looks like part 1 and part 2, where we had them underlined in purple and maroon. We'll do the same thing here. So for the first 2 terms, we underline it in purple, in maroon, and we can extract the 3x. If we factorize out the 3x, what are we left with? X. 3x by x is 3x squared, and plus 3. 3x by plus 3 is plus 9x. And for the next 2 terms, underlined in purple, we can pull out minus 5, so we're left with x plus 3. One of the hints in this is that when we're factorizing, getting this line, we will be getting the same brackets in both of them, if we do it correctly. Now we can write our final line. We can extract the x plus 3, and what we're left with, 3x minus 5 by x plus 3, and that's our final answer. Let's recall something, that for each one of these part 1, part 2, and part 3, how do we know if it is right? We can multiply it back together using different methods. There are many different ways to do it. One of the shortest ways is using FOIL. Many textbooks have that. The first term by the first term, the outer term by the outer term, the inner term by the inner term, and the last term by the last term. And if we do that, we should get back our top line. You can check our notes for further examples we did before on factorization and expanding of brackets. May 2009, number 2B. 1 packet of biscuits cost X dollars and 1 cup of ice cream cost Y dollars. 1 packet of biscuits and 2 cups of ice cream cost $8, while 3 packets of biscuits and 1 cup of ice cream cost $9. So, in part 1, write a pair of simultaneous equations in X and Y to represent the given information above, with 2 marks. So if you take our time, it's pretty simple. Just want to make sure you don't make any mistakes. So in the first case, we looked at 1 pack of biscuits, that's X, and 2 cups of ice cream, that's 2Y. So X plus 2Y is equal to 8. That's our first equation. And 3 packs of biscuits, that's 3X, plus 1 cup of ice cream plus Y is equal to 9. That's equation 2. Now for part 2. Solve the equations, and these 2 equations are happening at the same time, so they are simultaneous equations. Obtain B part 1 above to find the cost of 1 packet of biscuits and the cost of 1 cup of ice cream. So they want to find out what x is and what y is. Now, there are many different ways to work this out. We can use substitution, a graphical method, elimination, matrix method, Cramer's rule, and so on. So I've called at least 5 different methods there. What I've done in these videos, I've found that we'll be using substitution here to show you, because substitution works for every single simultaneous equation. So let's write. From equation 1, let's rewrite it. X plus 2y is equal to 8. So I can rearrange it, transpose it, make x the subject of the formula. So if I keep x alone on the left-hand side, then I carry across the 2y. The 2y is adding on the left. When I carry it across the equal sign, it'll get the additive inverse, which means to subtract. So it'll be minus 2y plus 8. So we now have x in the form of y. Now we can substitute that into equation 2. So we have equation 2, 3x plus y is equal to 9. And we know what x is. So we're rewriting it 3 by minus 2y plus 8, which we got from before, plus y is equal to 9. And we can go on by expanding 3 times minus 2y, that will give us minus 6y, plus 3 times 8, that will give us 24. And if you looked at our explanation of the videos before, what I did was draw little hooks from 3 times minus 2y and 3 times 8. So you can do that. You can look at the previous videos and see how to do it. And that will mean we have a line minus 6y plus 24 plus y is equal to 9. And now if we look at this whole line, there's only one unknown, y, so we should be able to solve it. Let's see. Minus 6y plus y will give us minus 5y. You can use a number line, or you can use a calculator if you're getting problems to double check. Minus 6 plus 1 is minus 5y. We already have 9 on the right hand side, and we're carrying across the plus 24 from the left to the right. And when we carry it across the equal sign, it changes from add to additive inverse or subtract. So we have minus 5y is equal to minus 15, because 9 take away 24 is minus 15. Now the minus 5 is multiplying. If I want to find y alone, I need to get rid of the minus 5. So y is equal to minus 15. And what's the opposite of multiplying? When I carry it across, it will divide. Minus 15 divided by minus 5. And 5 into 5, 1. 5 into 15, 3. And we have 2 of the same signs. Remember, if we have the same signs, then that will give us an addition. So y is equal to plus 3. Or we can just write 3 as is. So for both things to happen, both situations, then y, which is a cup of ice cream, must cost $3. That's what that's telling us. Now we didn't find out for the biscuits. So let's substitute y is equal to 3 into one of the simpler equations that we did before. X is equal to minus 2y plus 8. And we know y is 3, so we can substitute x is equal to minus 2 by 3 plus 8. Minus 2 by 3 is minus 6. Minus 6 plus 8. And that will give us 2. So what do we know? That when x is equal to 2, y is equal to 3 for this to work. And we can stop here. We'll get our full 4 marks for this part B. But we can double check it for ourselves. If we take x is 2 and y is 3 and put it into equation 1, let's try that and see. Then 2 plus 2 3s are 6. 2 and 6 is 8. So it works out. And let's put it into equation 2. You must check it for both of them. And we're going to get 3 by 2. 3 2s are 6 plus 3. And 6 and 3 is 9. So get into a habit that as long as we're solving for some sort of equation and we get an answer, we can substitute back into the original to see if it works out. If it was any other combination of answers, it would not work out for both equations. May 2010, number 2a. Given that a is equal to minus 1, b is equal to 2, and c is equal to minus 3, find the value of part 1, a plus b plus c. So we can substitute the values that were given above into this expression And that will give us minus 1 plus 2 plus, what is C? Minus 3. And we know that if we have a plus and a minus together, two different signs, then that will give us a negative. So we have minus 1 plus 2 minus 3. And that we can use our calculators, or we can use our number line, or we can think about it as we owe $1 and we get $2. What does that mean? We pay off the person and we have 1. And now we come and owe $3. So we had $1 and we owe 3, so we pay off the person. And that leaves us with owing $2 still. So the answer is minus 2. Now for part 2, b squared minus c squared. We substitute in again. B is 2. So we have 2 squared minus, what is 3? Minus 3 squared. And minus 3 times minus 3. 3 3s are 9. A minus and a minus means it's a plus, because the same signs, both of them have the same signs, it's going to give us a plus. So we can rewrite the line 4 minus plus 9. And we have two signs next to each other, and they're different. So if the same signs, if they were the same signs, they would add. So these are different signs, so they will take away. So we'll have 4 take away 9. 4 minus 9 is minus 5. For part B of the question, write the following phrases as algebraic expressions. So part 1, 7 times the sum of x and y. Remember, sum means to add. So when we're writing this, it's sort of kind of reading the question backwards. So we do the last thing that's written first. So first thing to do is find the sum. So we put in brackets x plus y. That's the sum of x and y. And then we multiply by 7. So that will give us 7 by x plus y. And for part 2, the product of two consecutive numbers when the smaller number is y. And the issue I found with my students were they didn't actually recall what consecutive means. Consecutive means it's the number that comes after the other one. For example, when we're learning to count 1, 2, 3, what comes after? That's 4. So the consecutive number to 3 is 4. And the consecutive number that comes after 4 is 5. Which means whatever number we have, the next number, we need to add 1 to it. So if we're finding the product means to multiply two numbers. The first number is y, then we're multiplying by its consecutive number. What's the next number? Y plus 1. So that will give us y by y plus 1. May 2010, number 2C. Solve the pair of simultaneous equations. 2x plus y is equal to 7. So we'll call that equation 1. And x minus 2y is equal to 1. We'll call that equation 2. From equation 1, and I'm going to use a substitution method to solve this one. Well, we can rewrite it. 2x plus y is equal to 7. So I can find for y alone. So if I want to find y alone, I need to move the 2x across. So y is equal to the 2x. What sign is in front of it? Plus 2x. So when I carry it across, it'll do the opposite, which is the additive inverse, which means we can write it as minus 2x plus 7. It doesn't matter if you write 7 minus 2x or we write minus 2x plus 7, it's the same thing. So now that we have it in this form, we can substitute it into the second equation. Whichever equation we're manipulating first, we then substitute it into the other equation. So we took equation 1, so we're going to substitute into equation 2. We could have done the other way. We could have used equation 2. You can try that. And let x be the subject of the formula. And substitute that into equation 1. It will still give us our same answers. So we substitute into equation 2. So that will give us, remember equation 2 is x minus 2y is equal to 1. So x minus 2, and we know what y is. Minus 2x plus 7 is equal to 1. Now that we have it in this form, we can expand by multiplying the minus 2 by whatever is inside the brackets. So that will give us x minus 2 by minus 2. 2 2s are 4x, and two of them have the same sign, so we're going to add. So x plus 4x minus 2 by 7. 2 7s are 14. We have a minus and a plus. The signs are different, so we're going to subtract. So x plus 4x minus 14 is equal to 1. Now, if we look at this, we have one unknown, which is x, so we can manipulate this equation to solve for x. So let's keep the x's on the left-hand side and move the numbers across on the right-hand side. So you have x plus 4x is equal to 1. And when I take the minus 14 and carry it across, it'll become plus 14. So we can now simplify that. 1x plus 4x is 5x. and that is equal to 1 plus 14, which is 15. So if 5x or 5 bags are equal to 15, how much is 1 bag or 1x? So x is equal to 15 divided by 5. And let's recall, how did that happen? The 5 in the line above was multiplying, so when I carried across, it did the multiplicative inverse, which means to divide. Or let's say differently, the 5 was on top, so when I carry it across, it will end up below in the denominator. So x is equal to 5 into 15, which is 3. Now that we've solved for x, we can substitute x into any one of the equations, equation 1, equation 2, the new form of equation 1, any one of those, to find for y. Since we have y is equal to minus 2x plus 7 already in that form, and we substitute for x on the right hand side, that will be easy for us to solve. So that will give us y equals minus 2 by 3 plus 7. And we know 2 3s are 6, and a minus and a plus, these signs are different, so we're going to subtract. So it's going to give us y is equal to minus 6 plus 7, which is 1. And as such, we've completed the question, because we have x is equal to 3 and y is equal to 1. You can resubstitute it into equation 1 and see if it works out to be 7, and into equation 2 to see that it works out to be 1. 2010, number 2D, factorize completely, part 1, 4y squared minus z squared. Now, if we look at that, we can't actually factorize anything out of either term right now. There's no number that we can take out. There's no letter. So we can take two terms and make it three terms. How do we do that? We create a middle term, which is actually 0. So we can rewrite it 4y squared plus 0yz minus z squared. And why do we have yz? Because the first term had y's in it and the last term had z's in it. So how many yz do we have? 0 of them, none of them. So we move from 2 terms to 3 terms. We can now move from 3 terms to 4 terms by taking the middle term, which we have underlined in green, and split it into 2. So let's recall how we do that. To do that, what we want to do is multiply the numbers on both ends. 4, because there's 4 is the coefficient or the number in front of y squared. And what's the number in front of z squared? 1. 4 ones are 4. So I can write that, show you as 4 squares. So 1 by 4 is 4. Can you rearrange this to find another rectangle? Yes, we can. We can shift 2 blocks down, so we'll get 2 by 2, which will give us the same rectangle. So either 1 by 4 or 2 by 2. Are there any other rectangles we can form? No more. So one of these pairs, it should give us our middle term, 0. So clearly we can see if we use 2 and 2, we can get our middle term. So there are a combination of ways to do it. Let's go through all of them to make sure you get a good grasp of this. Remember, you can go back and look at the notes that we did, the videos on factorizing and expanding brackets and so forth to help you. And let's see. If we take 2 and we add it to 2, so 2 plus 2, that is not equal to 0. We're looking to get the middle term 0. If we change the sign and put minus 2 plus 2, that works. If we put plus 2 minus 2, that also works. That will also give us 0. And if we put minus 2 minus 2, that does not work. That gives us minus 4. So any one of the second or third lines we can use to give us 0. So we can replace the third term, the green term, the term on the line there in the middle, by 2 terms. So we can rewrite 4y squared plus 2yz minus 2yz minus z squared. And if we go back and we look at this, the second and third terms actually gives us 0. And the 0 can be left out. So we can go backwards from the third line to the second line to the first line. So hopefully it makes sense to you. Why I'm doing this is because I found that many students are really in trouble when they come to factorization. So I'm trying to use this expanded version instead of a shortcut. I'll show you the shortcut after for you to get a better grasp. So now we've moved from 2 terms to 3 terms, 3 terms to 4 terms. Now we can take the 4 terms and split them. Take the first pair, let's underline that in maroon, and look at it. Can we extract anything from it? Yes, we can. We can extract 2, because we can get 2 from 4 and 2 from 2. We can extract 2. Can we extract any letter? Yes, we can. We can extract y. So we can extract 2y outside. So we're left with 2y, and what's left in brackets? 2y plus z. And let's see if we wrote that correct. 2y by 2y is 4y. And 2y by z is 2yz. Now let's look at the second pair. I underline it in purple. So what we can extract minus z from both of them, and we're left with the same brackets, 2y plus z. Many of my students rewrite the brackets first, 2y plus z, and look to see what comes out. So minus z comes out. Now the brackets are the same in both of them, so we can pull it out. So we're left with 2y plus z, and everything else puts in brackets, 2y minus z. And that's our solution to factorize this. Of course, there's a shorter way. Let's do that method. 4y squared minus z squared. What is 4y squared? It's 2y by 2y. So we can rewrite it 2y squared minus z squared. And that's of the form a squared minus b squared. Anytime we have anything of the form a squared minus b squared, automatically the factorization as a shortcut is a plus b by a minus b. So in this case, it will be 2y plus z by 2y minus z. Now for part 2, factorize 2ax minus 2ay minus bx plus by. And we have 4 terms. So that looks like our third line we had in part 1. So let's underline the first pair with maroon. What we can extract? 2a. So we're left with x minus y. And you can always check it. 2a by x is 2x. 2a by y is minus 2ay. And now let's look at the last 2 terms in maroon. We're trying to keep the same format throughout, so you can get a grasp of doing this. And what can we pull out? We can pull out the b, or we could pull out minus b. But what we want to get is the same brackets, the same x minus y. So how do we get x minus y? We need to pull out minus b. So minus b by x is minus bx, minus b by minus y, by, and 2 negatives, 2 same signs will give us a positive. So our second line makes sense from our first line. And now, can we extract even further, factorize more? Yes, we can, because both of them have the same brackets, so we can pull out x minus y. So we're left with 2a minus b. We put that in brackets by x minus y. That's also in brackets. And for part 3, last part, factorize this quadratic equation, a quadratic expression, sorry. So we have 3x squared plus 10x minus 8. And just like what we had in part 1 with only 3 terms, we can make it 4 terms. And how do we do that? We multiply the 2 numbers on the end, the number in front of the x squared, the coefficient, which is 3, by the term without any variable, without any x term, so that's 8. So 3 by 8. So we're going to look at that to figure out which pair we're going to use to break up the middle term. Remember, the middle term is plus 10x. We have it underlined in green. So 3 by 8 is 24. So let's see, can we form a rectangle with 24 squares in it? Yes, we can. 1 by 24. Can we form another rectangle with 24 squares in it? Yes, we could cut it in half, and we get a row of 12 by a row of 12, so 2 by 12. So we had 1 by 24, we have 2 by 12. Can we shift it even further? Yes, we can. We can say 3 rows of 8, or 8 rows of 3, it doesn't matter. Can we shift it even further? Well, we can get 4 rows of 6. All those are 24 squares. Can we get even further? Can we say 5 by anything? No, 5 by no 2 whole numbers multiplied by 5 will give us 24. So it's one of these pairs, either 1 by 24, 2 by 12, 3 by 8, or 4 by 6. One of these pairs we're going to use to give us our middle term. So we want to get 10x. So how do we get 10? We can either use 2 by 12 or 4 by 6. One of these will work and one of these will not work. So only when, there are a couple of ways to do it, but let's apply it and see. So let's use the 12 and the 2. If we take plus 12 plus 2, does that give us plus 10? No, it's not. They're not equal. Because plus 10 is not equal to the right-hand side, which is 14. So let's change the signs. All we're doing, now that we picked the pair 12 and 2, we're changing the signs from plus positives to negatives, right? And there are 4 combinations. We'll go through each one and see. So plus 10, is that equal to plus 12 minus 2? Yes, it does. 12 take away 2 is 10. And that's our answer. Let's try another one though, so we can go through it so you can get accustomed, right? And for students who are struggling, then you want to go through each step to make sure that you get it. For the third line, plus 10, that's not equal to minus 12 plus 2. Minus 12 plus 2 is minus 10. And for the last version, plus 10 is not equal to minus 12 minus 2, because that's minus 14. As such, we're sure that the second one, plus 10, is 12 minus 2. So let's go up on top now. And let's split the three terms, split the middle term into two, so we get 4 terms. So the green, which is plus 10x, becomes 3x squared plus 12x minus 2x minus 8. 12x minus 2x is plus 10x. So the second line is equal to the first line. That's why we wrote an equal sign at the beginning of the second line. Now we have 4 terms. Let's pair them off just like we've done in part 1 and part 2. Let's start with the maroon line. And what can we extract? We can extract 3 and we can extract x. So we get 3x on the outside, factorized out. And what we're left with, x plus 4. And let's see if we're correct. 3x by x is 3x squared. 3x by 4 is 12x. So I'm checking back each line. It's a very systematic, step-by-step, take your time. Factorizing an algebra is very, very easy as long as you go step by step slowly. Right, and for the second pair, minus 2x minus 8, which is purple, remember we must get the same brackets, x plus 4. So what do we want to put on the outside? We can pull out minus 2. Minus 2 by x is minus 2x. Minus 2 by 4 is 2 4s are 8. Two different signs will give us a negative. Now that we've known this, we can pull out x plus 4 from the third line because both of them have that. We could factorize that out. What's left? 3x minus 2. So we have 3x minus 2 by x plus 4, or we could write it the other way, x plus 4 in front and 3x minus 2. Both of them are correct. May 2011, number 2. Part A. Write as a single fraction in its lowest terms x minus 2 over 3 plus x plus 1 over 4. And what we've recognized over marking and teaching for many years, that students get problems dealing with this question. So the first step might be, let's rewrite it by putting in parentheses or brackets. So we'll write it as open brackets x minus 2, close brackets, all over 3, plus open brackets or parentheses x plus 1, close brackets, all over 4. So now take a look at it. And it sort of looks like a numerator and a denominator plus a numerator and denominator. Two fractions with different denominators. And how do you add fractions with different denominators? Well, we've gone through this multiple times in doing the solutions on computation and number theory. So if you're getting problems, you could go back and look at it from there, right? And the simplest thing to do would be to try and change the denominators in each of them to the same term. So with 3 and 4, we can either find the LCM or just multiply them either way. 3 4s are 12. So let's change each fraction, the first one and the second one, to something over 12. So how do we move from x minus 2 over 3 to something over 12? We multiply by 4 below. So that'll be 4 3s are 12. So we multiply by 4 on top. So that will give us 4 by x minus 2 over 12. And similarly, in the second term, how do we move from 4 to 12? We multiply by 3 below. 3 4s are 12, so we multiply by 3 on top. So we get 3 by x plus 1. Now we can rewrite this as one single denominator of 12 because both of them have the same denominator. And we can expand it up, the numerators. So 4 by x is 4x, 4 by 2 is 8, well, it will be negative 8 because there's plus 4 and there's minus 2. Different signs mean subtraction. Plus 3 by x is 3x, plus 3 1s are 3. So we're going to get 4x minus 8 plus 3x plus 3 all over 12. And if we look at the numerator, we have terms with x, so we can deal with those, and terms without. So 4x plus 3x is equal to 7x. Minus 8 plus 3 is minus 5. 7x minus 5 is all over 12. So we've simplified this. For part B, the binary operation, asterisk or star, is defined by a star b is equal to a plus b all squared minus 2ab. Calculate the value of 3 star 4. Now what it's simply saying is rewrite 3 star 4. So what we're doing is replacing the a by 3, like a substitution, and replacing the b by 4. So if we rewrite this, wherever we see a, we place it with 3 on the right hand side. Wherever we see b, we place it with 4. So that will give us 3 star 4 is equal to 3 plus 4 in brackets squared minus 2ab, 2 times 3 times 4. And we can solve 3 plus 4 is 7, so 7 squared minus 2 3s are 6 4s are 24. So 7 squared minus 24, some sums are 49, 49 take away 24, that will give us 25. So 3 star 4 is equal to 25. Part C. Factorize completely, part 1, xy cubed plus x squared y. And if you can see it, then we can skip the following line. If you can't, then let's expand. Xy cubed means x by y by y by y. There are 3 y's because of y cubed. Plus x squared y, 2 x's, x by y. And what's the same in both of them? I have it bolded. X and y is the same in both of them. So we can extract that. So xy on the outside, and what we're left with? Yy, which is y squared, plus x. And we've completed the factorization. We can check it back. Xy by y squared will give us xy cubed, plus xy by x will give us x squared y. Now, for part 2. Factorize completely 4 terms, 2mh minus 2nh minus 3mk plus 3nk. And we've done multiple solutions like this. So let's pair them off. Let's look at the first pair. We've underlined it in maroon. 2mh minus 2nh. And what's the same in both of them? 2 and h. So we could pull out 2h. We're left with m minus n. And we want to get the same thing by underlining the second pair in purple. And we want to end up with m minus n again. So if we want to end up with m minus n, we can extract minus 3k. If we extract plus 3k, then we'll get different brackets. We want to have the same brackets for both of them. When the brackets are the same, we can now extract or factorize out the brackets m minus n, given our final line, times what's the remainder? 2h minus 3k. And for part D, the table shows corresponding values of the variables x and y, where y varies directly as x. So we have a table, x is 2, y is 12, when x is 5, y is a, some unknown. When x is b, some unknown, we get y is 48. Calculate the values of a and b. So this is directly proportional. And we have videos on that, so you can go back, and we've done multiple examples, maybe 4 or 5 examples in complete detail, showing you how to do it. So I've just summarized it here. So since these are directly varying, y is equal to k times x. It can be written like that. And if we take the first pair, 2 and 12, well, we know y is 12, and that will be k times 2. Kx means k times determine x, which is 2. So 12 is k times 2. If I want k alone, then I have to move the 2 from the right-hand side and carry it across. So it'll be 12 divided by 2. So 6 is equal to k. So that means that y is equal to 6 times x, because k is 6. How does that help us? So if we look at our second pair, we're talking about the pair coming down, right, vertically. We know x is 5. So can we find y? Can we find a? Well, y is equal to 6x. That means y is 6 times whatever x is. So if we substitute a is 6 times, how much is x? 5. So 6 5s are 30. A is equal to 30. And y is equal to 6x. So if y is 48, 48 is 6 times b. 6 times some term. So we can find for b. To find for b, we need to get rid of the 6 from the right-hand side, so we'll carry it across the left. So 48, and 6 is multiplying. When I carry it across, it will be the multiplicative inverse, which means to divide. 48 divided by 6, 6 into 48 is 8. So 8 is equal to b. And we've solved the question. May 2012, number 2, part A. Factorize completely, part 1, 2x cubed y plus 6x squared y squared. Now, if you can see it, you can write the answer immediately in the next line. And if you can't, let's do this piece of work in. Let's expand each of them. So 2x cubed y would be 2 times x times x times x, because there are 3 x's, because it's x cubed, by y. Plus 6x squared y squared would be 2 by 3 by x by x by y by y. So let's see what's the same in both of them. I've kind of put it in bold. So we can see 2 in both of them. There are 2 sets of x's in both of them. There's a y in both of them. So we can pull out 2x squared y. And what will that leave us with? X plus 3y. And for part 2, 9x squared minus 4. And there are a couple of ways to do this. So I'll go through both of them. If we look at 9x squared minus 4, there's no number we can pull out. There's no letter we can pull out. So how do we deal with this? One way to deal with it is from 2 terms, make it 3 terms. How do we make it 3 terms? By putting plus 0 in the middle. There's nothing there, so that's 0. So we can rewrite the first line as we're writing 9x squared plus 0x minus 4. And how do we deal with this? We've done this before. 9 times 4, we multiply the ends, the coefficient of x squared and the term without x. So 9 4s are 36. So we're looking for a combination or a pair of numbers that will give us 36. And we did it in our last solution in May 2011, where we draw the rectangles and showed you, well, how do we get 36? We could get 1 by 36, right? That's one rectangle, or we could get 2 by 18, or we could get 3 by 12, or 4 by 9, or 6 by 6. And of course, we want to end up with that middle term underlined in green, which is 0x. So to get 0, we need to use two numbers which are identical, which are exactly the same. So we have to use 6 and 6. And when we use 6 and 6, that will give us 0. How do we do that? Do we say plus 6 plus 6? No, that's not equal to 0. Do we say minus 6 plus 6? Yes, that works. Can we say plus 6 minus 6? I'm just switching around the positive and negative signs, right? And that works too. Can we say minus 6 minus 6? No, that gives us minus 12, so that doesn't work. So either the second or third line, we can pick any one of those to replace that green term, that term 0x. As such, we can now rewrite the 3 terms and make it 4 terms. So we move from 2 terms to 3 terms. We move from 3 terms to 4 terms. So we now have 9x squared, and what is 0x? 6 plus 6x minus 6x minus 4. And we now have 4 terms. We can pair them off and factorize. 9x squared plus 6x, what's the same in both of them? The number 3 and the letter x. So if we extract 3x, we're left with 3x plus 2. 3 by 3 is 9, x by x is x squared, plus 3 2s are 6x. So we get 3 by 3x plus 2. And what will happen in the second pair? Well, it will give us the same brackets, 3x plus 2, and we can extract minus 2 from both of them. We can use extract plus 2, but then the brackets will not be the same. So we want to maintain the same brackets of 3x plus 2 in both of them. Now that we have that, we can write our final line, 3x plus 2, and what are we left with? 3x minus 2. So that gives us our answer. There's another way to do it, which is shorter if you recognize the method. 3x squared minus 4 can be rewritten as 3x all squared minus 2 squared. So this looks like the term a squared minus b squared, the difference of squares. And when you factorize that, it always gives you a plus b by a minus b, always. So 3x squared minus 2x will be 3x plus 2 and 3x minus 2. The same brackets, except we will have different signs. And for part 3, they're giving us one with 4 terms, which is 4x squared plus 8xy minus xy minus 2y squared. We also have to factorize this. This looks like our third line in part 2. So we can put our maroon and our purples and factorize each pair. So we can extract 4x from the first 2 terms. So that'll be left with x plus 2y, and check it back. 4x by x is 4x squared, 4x by 2y is 8xy. And we can pull out x plus 2y in the second pair. Same brackets, so what are you left with? Minus y on the outside. So minus y by x minus xy minus y by plus 2y is minus 2y squared. And now we can complete the question. We know that the same brackets in both of them. We can extract that or factorize it out. So x plus 2y by 4x minus y. And for part B, 2x minus 3 plus 5 minus x on 2 is equal to 3. We want to solve for x here. Now, how do we do that? Let's see if we can simplify that left side term. Now, we did something similar in the last past paper in May 2011. What we started off doing is by putting brackets around them. So we put brackets around each of the numerators, 2x minus 3 and 5 minus x, and we can change it to one common denominator. If we have 3 and 2, then we can change it to something out of 6. 3 2s are 6. Or find the LCM, which looks all the same if you don't want to multiply them. It doesn't matter. So how do we go from 3 to 6? We multiply by 2 below in the denominator. So we multiply by 2 on top. So we get 2 by 2x minus 3 over 6. Plus, how do we move from 5 minus x on 2 into something over 6? Well, we multiply by 3 below. So we multiply by 3 on top. So 3 by 5x minus 3 by 5 minus x will be 3 2s are 6. And all that is equal to 3. So what we're really doing is trying to simplify the left-hand side as much as possible before we actually deal with the right-hand side, which is equal to 3. So you could keep that constant. Right. Now that we've recognized that, then we can take 6 is dividing on the left-hand side and carry it across. So it will multiply. And how does that help us? What it does now, it gives us 2 by 2x minus 3 plus 3 by 5 minus x is equal to 3 6s. And we can expand. 2 by 2x is 4x. By 2 by minus 3 is minus 6. 3 by 5 is 15. 3 by minus x is minus 3x is equal to 3 6s are 18. And we have one variable, x alone, in this equation, so we can solve here. So let's solve. 4x minus 3x is x. And we can carry everything across, 18, and carry the minus 6 across, we get plus 6, and carry the plus 15 across, we get minus 15. So we get 4x minus 3x is x equal to 9. May 2012, number 2C. Solve the simultaneous equations. 3x minus 2y is equal to 10, so let's call that equation 1. And 2x plus 5 is equal to 13, let's call that equation 2. So, as I said before, there are many different ways to solve it. We did a couple of them using substitution method. So now we're going to use a different method, the elimination method. It doesn't matter, it will still work, any of the methods. So let's take equation 1 and multiply it by 2. So we have 2 times 3x minus 2y is equal to 2 times 10. Remember, multiplying 2 on both sides. So 2 by 3x is 6x. And 2 by 2y is 4y, will give us 20. So we have a new, it's still equation 1, we just wrote it a little differently. And let's do the same with equation 2. We're going to multiply by 3. And that will give us 3 by 2x plus 5y is equal to 3 times 13. 3 by 2x is 6x. 3 by 5y is 15y is equal to 3 by 13, which is 39. Now, why did we do that? Let's put them together, one under the other. Let's rewrite it. 6x plus 15y is equal to 39. 6x minus 4y is equal to 20. It doesn't matter which one we write on top or below. Right. And if we look at those two lines, let's subtract. So if we subtract, let's put our equal sign. 6x take away 6x is 0. It's gone. It's disappeared. 15y minus 4y. And if we think about that, we have two negatives. Minus, minus, so that two negatives, two same signs means they're going to give us an add. Same signs, add. So 15 plus 4y is 19y, so that's the left-hand side, is equal to 39 minus 20, which is 19. So we got 19y is equal to 19. So using this elimination method, what we did, we eliminated, we got rid of the x. How did we do that? We looked at equation 1 and equation 2 and tried to manipulate it so that x's would have the same number. So if we took equation 1 and multiply by 2, we get 6x. We took equation 2 and multiply by 3, we get 6x. So they both have 6x, we could get rid of it. We could have used another method in which we looked at getting rid of eliminating the y. So if we look at equation 1 had 2y and equation 2 had 5y. So we could take equation 1 and multiply by 5, that will give us 10y. And take equation 2 and multiply by 2, 2 5s are 10y as well, and use that method. So it doesn't matter which one you want to eliminate first. Now we could go and do that to find for x, or we can just simply substitute, which might be a little quicker. So we know 2x plus 5y is equal to 13, that's equation 2. And we know that y is equal to 1, so we can substitute in there. So let's rewrite it. 2x plus 5 by 1 is equal to 13. So 2x plus 5 ones are 5 is equal to 13. And if I want to solve for this, I need to get x alone on the left-hand side. So how do I do that? I want to get rid of all the numbers. So I move the plus 5 from the left-hand side to the right-hand side. So I'll rewrite it. 2x is equal to 13 plus 5. When we carry it across, it changes sign from addition to additive inverse or to subtraction. That's easier to see. So 2x is equal to 13 minus 5, which means 2x is equal to 8. So x is equal to 8 over 2, which is 4. As such, x is equal to 4 and y is equal to 1. That's the solution of the simultaneous equations. It means that if we substitute x is 4 and y is equal to 1 in equation 1, it'll give us 10, and in equation 2, it'll give us 13. So only these two straight lines, if we were drawing a graph, we would see that they intersect at the point where x is 4 and y is 1. May 2013, number 2, part A. Factorize completely part 1, 2x cubed minus 8x. And what can we pull out from there? We can see that we can pull out the number 2 from both of those terms, and we can pull out x. So if we extract that and we factorize it, it will give us our new line. 2x is equal to x squared minus 4. Now we have factorized it, but it can factorize even further. So let's recall x squared minus 4 can be rewritten as x squared minus 2 squared. And we've done that in a couple questions before. It looks at a squared minus b squared, the difference of squares. So if that's the case, a squared minus b squared automatically or quickly we can say it goes to be factorized as a plus b by a minus b. So we can rewrite it as 2x by x plus 2 by x minus 2. And we've completely factorized the question. Part 2, 3x squared minus 5x minus 2. So we have three terms. It's a quadratic equation, and we can factorize it by splitting up the middle term into 2. So 3 terms becomes 4 terms. Let's recall how we do that. In order to split that middle term, we want to take the two numbers on the ends, the coefficient of x squared and the term without any x in it, which is 3 by 2, and that'll give us 6. So how do we get 6? We can write 6, we can put 6 squares down to give us a rectangle, 1 by 6. We can shift it around to get another rectangle, 2 by 3. Is there any other rectangles we could get? We could get 3 by 2. It's the same as 2 by 6. And 6 by 1 is the same as 1 by 6. So we have two pairs, either 1 by 6 or 2 by 3. Which pair will give us minus 5x? Well, actually 1 and 6 will give us that, and 2 and 3. But for this particular quadratic equation, only one of those pairs work. So let's pick one and see how it works. So we're going to use 6 and 1. So let's say I'm going to do the whole combination again. We're going to say plus 6 plus 1. That is not equal to minus 5. We have minus 6 plus 1. Yes, that works. That's minus 5. So that will be the correct way. There's plus 6 minus 1. I'm just going to show you the others, right? The 4 combinations. Plus 6 minus 1 and minus 6 minus 1. And none of them work. So only the second one. So we can replace minus 5x and rewrite it as 3x squared. Instead of minus 5x, we'll have minus 6x plus 1x. I don't need to write the 1. The 1 is understood. X minus 2. So we now have 4 terms. Let's pair them off as we've been doing over and over. This is the 5th past paper question where we're doing the same thing, which is put a maroon line under the first 2 terms, and let's see, can we factorize that, and then purple under the next 2 terms. So what can we extract? We're going to extract 3x from there, and that will leave us with x minus 2. And we want to get the same brackets x minus 2 again, so we can take out plus 1. So we have 3x by x is 3x squared, 3x by 2 is 6x, 1 by x is x, 1 by 2 is 2. You see, I'm always checking the line I wrote to see if it's the same as the line above, right? And that line is now equal to, what can we do? We can extract the x minus 2. So we're left with 3x plus 1 by x minus 2. And we can write it in either order. We could switch the brackets around, and it's still going to be x minus 2 by 3x plus 1. It's the same thing, because 1 by 6 is the same as 6 by 1. That's the commutative law. Now let's go on to part B. Makes part 1, make C the subject of the formula. So they're giving us a formula, f is equal to 9 on 5 c plus 32. And we want to be able to shift it around to get the c alone on the right hand side. Right? Actually, this is the formula which converts Fahrenheit and Celsius. That's the connection in terms of measuring temperature. So we have plus 32, we want to move that across first. Plus 32 when we carry it across becomes minus 32. So we have f minus 32 is equal to 9 on 5. And 9 on 5 is multiplying when I carry it across, right? To leave c alone on the right hand side, it will do the opposite. The 9 which is multiplying on top will come below as the denominator, and the 5 which is in the denominator will go up on top to multiply. So we'll get 5 on 9 and put in brackets f minus 32. And that will be equal to c. And for part 2, given that f is equal to 113, so 113 degrees Fahrenheit, that's what it's saying, calculate the value of c. Convert the 113 degrees Fahrenheit to how much Celsius it is. So we know the equation 519 by f minus 32 is equal to c. We just worked that out. So we rewrote it and substitute f is 113. 519 by 113 minus 32 is equal to c. You have calculators, you can work this out. Or you can do it in your head, 113 minus 32 if you want to do that way. And that will give us 81, right? And 9 into 9, 1, 9 into 81, 9, 9 5s are 45. So 45 degrees Celsius is the same as 130 degrees Fahrenheit. May 2013, number 2C. 500 tickets were sold for a concert. So let's put an orange circle here to represent the 500. Of these, X tickets were sold at $6 each. So let's cover a portion in green and we'll label that X. So this represents how many tickets were sold at $6. And the remainder at $10 each. So what we're seeing remaining there will be at $10. Write an expression in terms of X for part A, the number of tickets sold at $10. So that's the remainder. So if the whole thing is 500 and the green part is X, then what we're seeing remaining will be 500 minus X. And for part B, we're still writing an expression in terms of X for the total amount of money collected for the sale of the 500 tickets. So if we consider that we had X tickets at $6 and we had what's remaining there on the left hand side at $10. So our total will be 6 times X plus 10 times what's the remainder, 500 minus X. And for part 2, the sum of $4,108 was collected for the sale of the 500 tickets. So they're telling us now the grand total. Calculate the number of tickets sold at $6 each. And which are the $6 tickets? The X amount. So we want to find X. So if we write back the equation that we had in blue and replace total by 4,108, so we have 4,108 is equal to 6x plus 10 by 500 minus x. It now moves from a question which happens in the real world to simple algebra to solve. And if we look at this, we can see there's only one variable, x. And as such, we are supposed to be able to solve it. So let's expand the right-hand side. 4,108 is equal to 6x plus 10 times 500, that's 5,000, minus 10 times x is 10x. So we can put all the numbers on one side and all the x's on the other side. We already have the x's on the right, so let's move the 5,000 across. So when we rewrite it, we get 4,108 minus 5,000 is equal to 6x minus 10x. And we can simplify both sides. The left-hand side will give us minus 892. You can use our calculators for this, or you can work it out. It's equal to 6 minus 10, which is minus 4x on the right-hand side. So if we want to find x alone, we want to move the minus 4. The minus 4 is multiplying on the right-hand side. When you carry it across, it will divide. So it'll be minus 892 divided by minus 4. 4 into 4, 1, 4 into 8, 2, 4 into 92 is 23. And we have two of these signs are the same signs mean add. So we're going to get 223 would be x. That means that 223 tickets were sold at $6 each. And if you wanted to double check, you could work out the rest, which would be 277 at $10, and you total it, and you would get back 4,108. We've now come to the end of CSEC past paper questions in the topic of algebra, specifically the questions that come in section 1 of the past papers. This video covered the past paper questions from May 2009 until 2013, and our next video will be looking at the next 5 years from 2014 until 2018. Feel free to look at the description down below so you can get an overview of all the videos and the order it should be looked at in order to get your better understanding of the CSEC Maths syllabus and a better grade in the CSEC exam.